Welcome everybody on this just beautiful Columbus Day, huh? 703. It's a gorgeous day today. My name is Bob Zurek. I'm the CTO and VP of Products at Infobright. And Infobright is a columnar database, thus talking a little bit about columnar and rows and even this topic of polyglot persistence, which is starting to bubble as a phrase out there in the industry about using multiple data sources or persistent data stores in the context of an enterprise. Okay. Just a quick background on myself. I've been with Infobright a little less than 2 years, and prior to that I was a CTO at Enterprise DB, which is the open source Postgres company. Yeah, it's a Postgres company with Oracle compatibility. Prior to that I was the CTO at Essential Software, which sold to IBM. And then I worked for IBM in the information management group for 2 years as a VP of products there, and then served stints at Sybase, at PowerSoft. I've done 4 startups, 1 failed, 3 successes, and been in the Boston area for quite a long time. So thanks for again coming out. So quick background, and if you want to connect with me, just feel free to LinkedIn. If you're in LinkedIn, just Bob Zurek and do a LinkedIn for networking. If you want to follow up with anything. I'd like to give you just a quick background on Infobright. I'll get into some of the Infobright technology because it is kind of the center of this discussion around columnar technologies, but we'll also be talking about how it differentiates from row-based technology or typical row-based technologies that exist out there. We are known as one of the first commercial open source careful. Analytic database. Our focus is on analytics because that's where we're getting a lot of traction. We have phenomenal customers, and they range from one of the largest multimedia companies on the planet, have amazing adventure parks, to Major League Sports organization. We can't mention their names because the brand is highly protected and requires a great deal of carefulness, if you will. But some interesting companies I'll talk about: Bango Networks, how they're using our technology. We've worked underneath MySQL as kind of a super storage engine, and then have great partnerships out there with a variety of companies, from the usual suspects in the business intelligence and reporting area. Talent is one, Jasper is a phenomenal company. Lots of great momentum. We have well over 120 customers. We had a great quarter this quarter. The business seems to be doubling in size. We are probably the most widely used storage engine outside of InnoDB and MyISAM. So if you look at all the storage engines out there, we're probably the one that's commercializing it successfully.
What's a storage engine?
Storage engine is the ability under MySQL to unplug the way data is stored and managed for a particular use case. So with MySQL, what ships today with the latest release is InnoDB, which is really known as a high-volume transactional database system or database storage engine underneath MySQL. Here's MyISAM, which is file-based storage, and then basically there's an API that developers can program to replace or to plug in an alternative. You can plug in your own optimizer. You can plug in at the very top layer, where you can get a parse tree and then take it from there. And I'll show you an architecture, high-level architecture diagram of how we operate. By the way, I love interactive, so if you have any questions, don't hesitate to stop me, get clarification.
Another question.
Sure.
Do you sell only storage engine, or you have something else as well?
No, I would call ourselves more, we're above and beyond the storage engine. We have our own optimizer. We store data in columnar format. We have some very deep compression capabilities that's plugged in also under the hood. So, but we have to interface. The reason why we chose MySQL is obviously the big ecosystem that is out there today, the wide range of skilled developers on the topic. So one of the things that you'll find is if you're a MySQL user and you're very comfortable with DBA, you'll find that using Infobright is a real simple switch, you know. And in fact, I think the T-shirt says it all when it says, let's see if I can pop one of these open. You know, simply at the prompt, once you have us installed, although you don't have to do this, you know, you do use Infobright and the database is changed, and then you can start plugging away using our technology. So it's pretty quick. I can kind of jump into the product itself.
Sorry.
Yeah.
I think I'd seen a presentation in this group on Infobright probably almost a year ago.
Yeah.
On column-based storage.
Yeah.
And at that point, the Infobright engine,
Yep.
it interacted at deeper levels, so it wasn't really one
Yeah.
that could plug into your existing MySQL instance.
A couple things I can kind of clarify that. When you download and install our Community Edition, you're actually getting a version of MySQL. So you don't have to have an existing MySQL implementation. We OEM MySQL because we're commercial open source. We have a commercial open source version of commercial version called the Enterprise Edition. And that is, for us, it's a very long-term contract, so you don't have to worry about, you know, MySQL disappearing soon from us. So essentially, we have MyISAM with that distribution, so we have row and the columnar offering from Infobright, so you can switch and start, you can use MyISAM for whatever row-oriented processing you want to do for the file system. It's very, very fast. And
Yeah.
then you can switch back and forth, and you can move data between the two systems.
But it's not you wouldn't, to use Infobright, you wouldn't be able to maintain your, so if you have a distribution,
Yeah, we have our own version.
5.1 whatever,
Yeah.
you can't stick with that. You have to go
That's
to
right. Yep.
an
You have to,
Infobright.
yes.
Even if you don't use the column bit. You know.
Right.
Okay.
Yep. Okay. Lots of visitors, lots of downloads, lots of community. The community's growing fast. We're actually now above 12,000 members in the community. This is a very hot topic in the analytics space. People are just digging into this columnar subject area. There's a number of companies in this space. Vertica here locally, which is a Dr. Stonebreaker company. They're a commercial columnar database, much different than us. There is a company called Aster Data, another columnar database system. So if you're into kind of database technology, looking more on the analytics side, you'll find us there along with several other peers in the industry. Okay. So I think I don't have to spend a lot of energy on this particular side because data is where it's at. I mean, Java programmers, no offense to anybody, they're a dime a dozen. Same thing with, you know, it's all going offshore. You know, the rates for contractors are dropping down. On the other hand, database technology, if you look at the Bureau of Labor statistics, the fastest growing segment in software technology is database professionals, database administrators. It's growing faster than anything out there right now. And again, I don't mean to offend anybody. Programmers are great. You know, we couldn't have this technology unless we had great programmers. But again, a lot of Java programmers, a lot of C, C#, PHP, Python, Perl, you name it. People, multiple languages out there, very experienced. But when you get into the data subject, it gets challenging at times. You have to deal with things like the growth of data. You know, that's happening. People are trying to get insight on what's going on with the data. There's a lot of drive by the executive teams at these businesses saying, I want those reports fast, I want them the next day. And then a lot of technology is moving to software as a service, so in that model there's certain SLAs. So you'll hear later on about a company called Bango Networks, which is a real hot company, which is a great customer of ours. They're experiencing phenomenal growth, and it's because of the number of media companies that are actually subscribing to their analytic services and their billing services in the mobile space. So for you at Nokia, you'll definitely should take a look at this company called Bango. They're pretty amazing. And I wouldn't already Google. I think Google tried to scoop this company up, and I think they said no, thank you. So I don't expect them to be out for much longer. Okay, so I am going to dig down deeper into Infobright technology and the columnar topic, but for some of you that are not like deep into the database technology, understand that very traditional way of managing and storing data with the popular database systems out there have been storing information in row format, right? So, you know, columns, tuples, rows, all those good nomenclature on top of in this technology. So here you have a standard schema, very simple schema here with employee ID, job, department, and city. In the row-oriented databases, data is stored in rows. In the columnar, pretty straightforward here. The data itself is persisted and stored on disk in columnar format, and it gives you a lot of advantages. I'll explain.
What is do you have some kind of hidden internal ID that ties the position in the columns together?
I'll
so
go.
you can reassemble?
I'll dig down. There's some really interesting IP here in Infobright's infrastructure. So yeah, if you can bear with me, I'll drill down into a little bit deeper. So you might say, so what are row-oriented databases? This is not, I'm not trying to dish row-oriented databases at all. They're great. There's phenomenal success out there with technologies from everybody from Sybase to Microsoft, Oracle, the usual big cast of characters that exist out there. But it's all about online transactional processing, right? OLTP. A lot of transactions happening really fast. Whether it's in the financial market, whether it's manufacturing, it's in the sales management process. The other part of row-oriented, there's a big focus on ACID requirements. This means that it's industrial strength, that when things go awry, then they're managed and controlled by the database to ensure consistency, integrity of the data, automaticity of the data. It uses a traditional relational model. This is typically known as ER for entity relationships, so things are related from one to another, so mathematically this has been the heart of the technology under the hood when it was first kind of brought to bear by Dr. Codd in the early days of IBM research. The other thing that's typically happens is all the columns are required to satisfy a particular query, so if you're bringing up on a customer account, generally the customer ID, the customer's first name, last name, everything is looked at by the particular customer rep. A lot of inserts, a lot of updates, a lot of deletes, and then a lot of CPU horsepower is taken up. So you'll look for scale-out technologies in this particular area, and NODB is a classic example in the MySQL world. Okay. Other players and innovators, the PostgreSQL database is a great database system, open source, a great team behind and community behind the engine. Some new innovators here locally. I think you heard last month from Tim Callahan over at VaultDB and present, and again the big players, Oracle, Microsoft, on and on. The other thing that when you begin to jump into this topic of columnar, what you'll find is typically they steer away from heavy transaction systems and steer you more towards the use cases of analytics. So a lot of read mostly, a lot of reading of the data. A lot of big data, so you'll hear the discussion columnar sitting in the big data bucket here, along with NoSQL and Hadoop and all the other cool things that are happening out there. And customers usually here are hitting the wall when it comes to a performance perspective. So the queries are taking, hours, 5-hour queries, And what's happening for us, at least, people will grab the community edition, free and open, they'll download it, they'll take their transactional database, like maybe SQL Server, they'll move the data over into Infobright, give it a try, use our bulk loaders, our parallel loaders, the MySQL loaders, bring it into our engine, and then start firing queries to actually compare how performance is going. And what they do is they see some very dramatic differences. Okay? So they need fast access to new data. Again, in the case of Bango, one of our customers who was originally running on SQL Server moved over to us, and you'll see some of the statistics, and these are customer statistics. It's nothing we did in the benchmarks inside our organization. It's actually what Tim Moss, the Chief Data Architect, provided to us from Bango. There's also access to detailed data, access to aggregate data, so there's a lot of sums, so on and so forth, summing and aggregation of data. And the other thing too is people are looking to really steer away from complexities, both in database administration. They want it to be easy to implement. So one of the things you'll see in Infobright's technology is there is no requirement for indexing. In fact, we don't even support the create index statement. So when that happens, we'll just error out as far as the indexing. There is no need to futz around with indexing, whereas in the row-oriented systems, again, Oracle, SQL Server, you're constantly trying to performance tune your engine by applying indexes. Not only that is when you apply indexes, the database size will actually bloat. You could easily go from 150 gigabytes to 300 gigabytes by applying indexes. Okay? And in our case, people are trying to store a lot more data with a lower footprint, so they look for things like compression. So you'll see in our technology, and I'll talk a little bit more about this, is we go to 10 to 1 to 50 to 1, one customer 98 to 1 ratio on compression. So if it's a 500 gigabytes, it's easily in the 10 to 1 going down to 50. So that's a very important perspective here, because people again want to store more historical information to query. Questions?
Yeah, so obviously you're positioning for reads, and that's fine. I'm curious, on writes, is the performance on writes similar to the performance of a heavily indexed relational database?
On writes, depends on the queries. It depends on the queries. Simple insert updates or deletes extremely fast. In fact, we don't, most of our time and energy these days has really actually been on the DML. So the data manipulation language, the insert, update, deletes. So in this latest release, we've added significant performance enhancements for inserts. So we spent a lot of time on inserts because in this analytic world, either you're going to use the loader, the bulk loader, and like take a bunch of data and throw it into the database through a parallel-based load, or they're going to fire, several hundred inserts and do it that way. And so in this rev, we've gotten on average 1,000% faster on inserts. On the DML, on the updates and deletes, you're looking at anywhere between 40 and 500% improvement. So you'll see the columnar people pay attention, but it's not necessarily the center of what users are asking. They're just saying, can you squeeze 5 hours down to 5 minutes or 5 seconds? And that's where we spend ours. But
when I think of the storage system of all columns,
yeah,
is thinking of an actual index update for a new piece of data the right way to think about that?
Well, in our world, no. Not at all. You don't
No, I
have to
don't
do
mean the insert of the row. Got it. That's
Yeah.
not there. But you need to take apart the row, right, and stick stick a column,
Yep.
each column, into a separate data structure.
Right.
Do I have that right?
Yes. Yep. And the question is, are we slow at that, or?
Well,
Min-
regardless of your algorithms, I'm trying to just in my mind just understand it architecturally.
Okay, I'll go into it.
I'll wait.
Just a quick question.
Sure.
Out of touch. I worked on Sybase IQ back a bunch
Sure.
of years ago.
Yeah, it's a
And
great database.
The big thing was, of course, the TPC versions of the benchmarks. Are you guys running those now, the various versions of TPC, or are those out of favor?
No one asks us for TPCH benchmarks or TPCC benchmarks.
So we spend half of our
What they do? What's that?
we spend most of our time, trying to run like the terabyte, TPC.
Yeah,
whichever we went.
that is so
Those are all TP benchmarks anyway, mostly, right?
Well, yeah, I mean, they certainly, yeah, right. But again, in the wider marketplace, people were certainly interested. Both, IQ was very good at delivering, queries extremely fast. But then the concern became, well, how fast can you update? How fast can you, update the transactions? So they put a lot of work into doing that.
Yeah, there's a couple of comments I would make. One, to do like really rigid TPCH benchmarks, you can spend a boatload of money and a boatload of time. And it's really to address the vendors' competition, war, the competitive war. And people will say, well, they didn't do a TPCH. And most of our customers, they just want to know, how fast are you when I ask questions of your database and exists? And if it meets their thresholds, then that's all they care about, especially if it's pretty dramatic. And people will generally see a pretty dramatic shift for us. So we don't, we have been forced into testing against competitive offerings in the market. And what we generally do is go to an independent source, because no one's going to believe us if we run it, and they're not going to really believe the competitors. But here's something to keep in mind. You can run benchmarks, but what you'll find is that, especially competitive stuff, is that they'll try to show off the performance characteristics a lot, and especially in our space, but it turns out that they only support a minimal subset of the actual SQL language. So there are certain SQL statements like subqueries, left out or join, they don't support. So you could have the best benchmark numbers in the world, but if you don't support typical queries that are required inside the types of businesses that buy us, then doesn't help you at all.
I guess, well, in that case, I mean, I'm not familiar with many databases that wouldn't support those things at this point in time.
Oh, there
Welcome
are.
to Boston.
Yeah, there are certainly database systems.
Yeah.
We have a
Sort of
competitor.
disappointing.
We have a competitor that claims to be faster than us, but that was done on like a 6-month-old release. But it turns out when we did the benchmark with a third party, they did it, and they found it was actually slower, and they had limited SQL support. So.
And it's hard too, because it doesn't matter how fast the benchmark is, if your system, if the queries that you're doing are slow, you know what I mean? Because it always ends up being
without some sort of apples-to-apples comparison of things, and that's what TPC purported to be. You can play fast and loose, and Oracle typically put enough memory on the system so they can cache the entire database, in memory, and so things were really fast if you cached everything all the time.
Yeah, it served the purpose at its time. But now most of the
With internet, the load and the variety of the transactions became significantly different than it was at the TPC time.
Sure.
That's probably one of the reasons why it became less essential.
it's usually
Proliferation of databases these days is all about there's special needs and there's a solution for each one. Can I ask you, in your population of people that use Infobright, how many use it as the database of records versus how many use it as there's a transactional database and nodes?
No one really uses it as a transactional database. It's all as an analytic database.
So they ETL it over
Yes.
to your stuff and then
Yeah.
use it for
So
purposes.
here, yeah.
Well, that's what it's for.
Yeah, exactly. It's worth opening up the conversation about this. If you're a major online retailer, and you're selling whatever, you're going through big growth, and people are ordering your products, and your transactional systems are supporting the execution and sales, that sales transaction. But your executive team wants to know, like at companies like the Gap, for example, want to know, what's the hot shirt, what's the printed shirt. They've got to ask questions about what's selling and what's not selling, so they can adjust their inventories accordingly. You cannot ask those questions of a transactional system during the transaction processing that's supporting the 24 hours, 365 effort. You try to ask those queries, fire those analytic aggregation type queries about those systems, against those transactional systems, you're just going to bring it down to your knees. And I remember when I was at, just to give you an example, I remember when I was at Enterprise DB, FTD was one of the customers, and what had happened was they were, starting to ask the analytic queries, and it really put a lot of constraints on the actual engine itself. Things were slowing down, so they offloaded things in via ETL, extract, transform, and load, and then ran the analytic queries and found a much different. So that's typically what's happening, and that's people are beginning to. Columnar is getting more and more mainstream.
I would add to what you're
Sure.
saying.
Yeah,
that
please.
When you do,
I mean,
when you do transactions, you accumulate more data, and after some times, your data became dead from transactional point of view. They became old, and almost nobody updates them.
Yeah.
It kind of gradually you convert from OLTP into OLAP. You know that because data 1 year old, nobody's going to update them. The customer's no longer interested in that. It's very rare that customer refunds something after 1 year of usage. So that's essentially, you have to deal with that data. They're essentially reading not through transactional type of processing.
Excellent point, and this revolves around the topic of currency of the data, right? How long do you have to keep that data around? Is it 30 days? Is it 15 days? Is it 7 days? On the analytics side, it's 30 days, 60 days, it's a year. They want to kind of look at the trends, and then more and more predictive, based on a historical perspective, what can we expect in the future? Okay. So, I think we probably beat this to death. Again, this is not like one versus the other by any means. I don't want to tell you, get off those transactional systems and run over to Infobright. I'll say get off the transactional systems to do your analytic queries and potentially use Infobright to execute that.
So what does that mean? Only relevant columnar?
Yeah, so in the case of columnar the columnar approach, it's querying the average age, so you're only going after one column, if you will, instead of multiple across multiple columns, and it runs very fast, especially when you're doing things like sum, count. In the case of Infobright, a lot of the aggregations will actually happen at without hitting disk itself, so it happens out of memory. So when you do certain aggregations like sum or range of data, that'll come right out of memory and not even hit disk, okay, and not go through, say, a decompression to shoot the data up. Okay. So I am like a use case fanatic. It's something that we spend a lot of time at Infobright is like, where are we getting traction? What are the types of use cases people are where we're best fit? Because the last thing we want to do is have, spending a lot of time when really talking to customers and prospects when the requirement is really heavy transactions. That's not a good fit for a columnar database system, and I think anybody that's in that space and deep down into the space will agree with me, I believe. Okay, so on the best fit for dynamic analytics and static analytics, see what happens is there'll be a lot of what-if analysis, a lot of changing questions, ad hoc queries in our world. But there are certain cases where the queries are not ad hoc. They're very static. They will always be the same, right? And some systems, columnar systems, do extremely well here on static analytic queries. So the query is always fixed, right? And again, with transactional systems, you can try to add a lot of indexing, and that will help. But what Infobright does is able to handle both the ad hoc queries, the static queries, and the ad hoc queries here in this case. Right? So These are kind of mixed workload queries. These are very analytic in nature, and obviously these are a lot of DML going on in the background.
When you say limited joins,
Yes.
what do you mean?
A lot of times in this world, there's just not a lot of joins going. In fact, what you'll find is people are kind of tuning their model to tune to the benefits of the columnar. So you'll see very wide tables, lots of columns, rather than a lot of facts and dimensions and things that you would normally have to use join algorithms. So basically, they'll fetch it all out of one big table.
Hence your next slide.
Yeah.
So not normalized, really denormalization.
Yes. Yeah. Yeah.
Well, yeah, and part of it is when you have a columnar, I'm assuming it's the way with Infobright, this is my understanding of columnar in general, is that instead of having to put null or blank in columns that you don't have a value for, it just doesn't appear in that column, basically.
That's right. Yeah. Yeah. Okay.
Which is, I guess, another reason that sums and counts and stuff are even faster, because
Yes.
not only do you not have to go to, whatever, but you don't have to, add in the zeros and the ones, the null values, and nulls are very expensive in MySQL.
Yes. I might as well throw this out to the topic of NoSQL,
Especially saying.
because that tends to kind of come into some of the conversations. And so I tend to say, okay, we've been talking about role-oriented and column-oriented and some of the pros and cons, and then you have this whole topic of NoSQL, which is amazing, by the way. There are so many things popping out of the woodwork in this particular subject area. You could just, go to any of the NoSQL conferences, and there's a lot of people, there's a lot of interest in it. There's a lot of conversations about the people switching off of MySQL and getting rid of it and going NoSQL, like at Twitter or whatever, and Facebook and the big players, and you'll find that, no, actually that's not the case. There's a lot of this polyglot persistence going on. In other words, for the particular requirement, they may be using NoSQL for storing unstructured profile information, whereas any of the transactions that happen, they'll use a transactional database, and if they want to do a lot of intensive analytic queries, they'll do that too. So just like programming languages, right, where the programming language of the web has been typically PHP, Perl, scripting oriented, right, and then for back-end middleware type processing, Java has been a choice, or .NET for back-end processing. And you'll have different projects during different languages in the same business, right? The web developers, the enterprise developers, so on and so forth. And this is the case with the various database technology. I mean, I can't tell you how many customers, we have customer USAA, which is the military insurance company. They're using Infobright, but they're also using DB2, and they're probably using Oracle. Okay, so, and they're not going to necessarily throw those particular systems out. So you'll see people using multiple databases, and in fact, there's been a lot of market research on this particular topic. So there's a lot of different categories of NoSQL databases here. There's graph databases, which is kind of categorized into NoSQL. This is not intended to be a big NoSQL conversation. This probably sounds like a good topic to talk about anyhow, but there's been a lot discussed in the industry. So typically you get into document-oriented databases, you get into this topic of key value, popular companies, MongoDB, CouchDB. You don't have a fixed particular schema, a set of rows and columns. You have an identifier or a document, and it could look like this. Okay, and then the fields in the engines can have multiple pieces of information in them. Okay. And the big question is, when would you use NoSQL? And a lot of times, these are the things that begin to show up. So things like Hadoop are used for very complex, very complex set of algorithms that need to run against very large sets of data across distributed sets of machinery. MP3s and PDFs, I will tell you, you don't want to necessarily stuff those into Infobright. Okay. And then any of the transient data that may exist. So these are kind of typical use cases for the NoSQL solution out there. It's interesting enough, the folks at 10gen, which is the company behind MongoDB, is a sister company of ours in the Flybridge Capital portfolio. They're one of our investors. So we get to talk to them quite a bit. Roger Bottomer is one of the VPs of development for them. And Roger and I have spoken on a number of times. Now, people will point out there are limitations, and in fact, it's the NoSQL team members that are pointing out the limitations. Like they'll say, there's no transaction, it's around simple data. We don't do joins at all, because they're trying to get away from the joins because the joins tend to degrade, cause performance limitations, and complex ad hoc queries are almost impossible. So, in a very documented-oriented data model. So, the big question is, can they exist? Just like I was talking about with languages, you're going to see a lot of this. And in fact, if you look at what's going on with Cloudera, which is kind of the MapReduce Hadoop distribution, that's the company, they're teaming up with columnar and analytic database systems to do moving data out of HDFS, the Hadoop distributed file system, into, say, an Infobright, and then doing the SQL queries and getting information out in and out of the database itself. So there's a lot of complementary things that will happen. So this is not unusual and won't be in the future. So the point is, all of us can live together, whether it's a transactional database, whether it's a columnar database, whether you want to use NoSQL approaches. Certainly, you've got to pick the best solution that's going to give you the best results. And here, not every business can only use just NoSQL. And I think the NoSQL people will tell you, and we'll tell you that too, that you're not just going to use columnar for everything, because we wouldn't point you in that direction. Okay. Relational databases scale, NoSQL, because there's talk about they don't scale to the web and things like that. Untrue. I think they'll find little cases. These guys will find cases here. And here's a quote. I'm using MySQL, MongoDB, and Redis all in one application. So traditional web apps for MySQL, Mongo for logging, and Redis for tracking users, if you missed anything. So that's a quote. So, at this point, any questions, comments? You learning something new? That's good. So, we position ourselves as a high-performing analytic database system, very low footprint, very fast. You can get us, Sam, we are across operating systems, whether it's RHEL, SUSE, we run on Solaris, and then we're a first-class engine on Win32 and Win64. So if you were to take Windows, our Windows version, go to our download site, pretty much guarantee you'll get it up and running in less than 10 minutes. So that's from finding it on the site, downloading it, and getting it up and running. So the footprint is extremely small. One of the things that is commonly discussed in this particular space around big data is using hardware to drive performance rather than optimized software to drive performance. So our approach is very unique, and it takes a little getting used to as far as understanding how it operates. But once it clicks, people begin to say, I get it now. I see how this works. And I can see why you don't necessarily have to have an MPP version of Infobright. Generally, in the analytic database space, the data sizes, the data ranges are about 150 gigabytes to 7 terabytes, right? And then there's always going to be edge cases where it's 40, 60, several hundred, okay? In the case of Infobright, we're in that sweet spot. So we do extremely well into the tens of terabytes range. Certainly, we don't, if someone says, look, we've got, you know, a petabyte or 500 terabytes, we go get the forklift, bring in Teradata or Netezza or any of those big appliances and, you know, go to town. That's not what we're going to be able to address that particular topic for you.
What's a realistic, I mean, you gave a very wide range there.
Yeah.
So, I mean, what's a realistic tested use case for right now?
Probably in the 5 to 7 terabytes is where, that doesn't, I'm not suggesting that's a limitation of the technology, but that's generally, it's in the 150 to about 7 terabyte range, right? That's about 85% of the data warehousing, and that's not me, that's Forrester and Gartner and the rest of the analysts talking about.
Architecturally, why is a petabyte a problem for you?
We're SMP based.
So you couldn't?
We're not multi-node. You can, in version 3.5, which is in beta right now, there's replication.
But there's nothing architecturally limiting you.
No. In fact, what we're trying to do is perform extremely well on a low hardware footprint
Right.
in the ranges of data that are 80% of the requirement out there. And we do that extremely efficient, you know, and we spend a lot of time optimizing to run extremely efficient in that data range. And with the key feature of simplicity. Right now, when you get into scale, what happens in our space, people will say, competitors might come in and say to the customer prospect, oh, Infobright doesn't scale. So they'll just generalize and say they don't scale. And people will say, what are you talking about? They showed us bunches of customers that are scaling extremely well on this SMP, you know, low-cost footprint. And what you'll find is the business models of some of our competitors rely, the only way they make money is by going, when you go multi-node. So they spend more time trying to convince you that you're going to have to go multi-node and deploy multiple machines to support the scale, because that's the only way they make money, because they sell on that multi-node. And but that adds another layer of complexity. So our job number one is to run very efficiently on low cost for the sweet spot. And then when we go multi-node, which is, you know, in the works behind the hood, then that will maintain the simplicity and the performance that we would get. So we're adding replication for high availability. We're adding replication for sharding, if you wanted to go down that path. So that's how we're tackling it at this point.
So you say you're adding that for future releases?
Yeah, and 3.5 beta, which is out now, has replication support. And this is, most of the reason why replication is in there was customer requesting HA. Okay. But we have partnerships with SteelEye. We as a partner for HA prior to 3.5 release. So the key things that you should understand about this Infobright technology is really that we're column oriented. We use something called data packs. We compress the data packs. We have something called the knowledge grid. I'll talk about it. And then we have our own optimizer. So let's talk about what happens. So when you load Infobright from, you know, you ETL it in, or use the MySQL loader, we take that data and we start looking at it and we gather a bunch of metadata on that data, and I'll explain what some of that metadata is. As soon as it passes through this layer of gathering the metadata, it begins to break up the data into these 64K blocks called data packs. Those data packs are then laid down on disk after going through a fairly sophisticated set of compression algorithms. Okay, so I'll explain why these things are broken up into 64K chunks. So the compression algorithms are iterative, and it goes pretty deep depending on the data types. For example, character data compresses differently than numeric data, things like that. So these are kind of the typical compression, 10 to 1, 40 to 1. And so a terabyte goes down pretty deep, and in fact, you know, if you've got 500 gigs, it just going on a conservative 10 to 1 compression, go down to 50 gigs. And this knowledge grid, the layer that's storing the metadata, takes less than 1% of the compressed data. Okay, so we do maintain another set of data, and this is kind of the metadata. I'll explain what's in there. Any questions on this? Yes?
Do you see customers using like star and snowflake type schemas?
Yes.
Going away from those and going into this flatter?
It's a great question, yeah. You'll see they'll have a star snowflake schema, and then they'll begin to kind
And then
of...
do they see this kind of compression?
Yes, yeah, great question. It's very interesting what happens, when people really start using the product and start seeing and making certain adjustments in their model. And the performance is amazing. Our biggest struggle right now is...
For that question.
What's that?
Can you help me a bit with that question?
Yeah.
Why does...
People will begin to flatten they'll flatten.
Okay, so a star
They'll
schema
denorm-
is a solution to very large data sets, but if you compress it, you don't have
Yeah,
to. Is that-
it's right now it's all over the board. We'll get people using, they'll have star and they'll have snowflake, and then they'll take some of that and they'll flatten it and they'll denormalize and things for performance. They don't have to. They'll still get compression and things like that. They don't have to, but
But in like a
That's what
star and snowflakes, you have indexing and you have a lot of large objects getting created
yeah, you have
because of that.
facts and dimensions and things like that. Yeah.
But you do have to in order to not do the joins.
What's that?
You do have to, and not do the joins, you have to change the scheme.
You may, yes. Yep. Okay. So let's walk through this capabilities of ours on the knowledge grid, because this is kind of where the secret sauce is of Infobright. So again, the data comes in, we begin to break it into, gather the metadata. We call it knowledge grid, don't confuse it with grid computing and things like that, right? And there are a set of what are called data pack nodes. We create a numerical histogram, I'll dig down into that. For numeric information, we create a character map for string information that's coming into the system. And then we create a relationship map, which is called a pack-to-pack node, which is held in memory, and those are created dynamically on the fly during the context of a join inside Infobright. Okay. So let's go into this a little bit deeper. So this is the numeric histogram, right? So this particular knowledge node, these are a set of knowledge nodes. Again, the histogram and the character map and the pack-to-pack node is where we gather the statistical and aggregate information. Okay? So in this case, we're able to capture min values, max values, all these different kind of potential data information or information metadata that could be part of a query. Okay. So when a query comes in, sometimes it has the information right at the knowledge grid without going down and looking at the information down on disk. Okay. Now, these numerical histograms are divided into chunks. These are 1024. And what happens is we have this binary representation that keeps track of the numerical values that exist inside those data sets. Right? So if the min-max range is less than 24, then each interval has its own distinct value. So down here under the hood, we can see that there's data that exists in this particular range, there's data in this range, where the 1's and the 0, there's nothing that exists here. So this is using rough set mathematics. We're pretty much known for, leadership in this area of math. A number of our core technologists are at the University of Warsaw in the mathematics department in Poland. A gentleman named Dominik Slezak was the president and chair of the Rough Set Mathematics Society. So when they go out and give academic presentations, it's along how rough set mathematics is being used under the hood at Infobright. We have a number of patents in this particular area. And the character maps, this is, again, another way of representing the textual information that's sitting inside the data packs at this metadata layer. So in this case, we have the first 64 positions of the text fields are red, and then we begin to provide indicators of the location of the string information so that when a query involves a string, we can find that extremely fast and eliminate information or data packs where this data is stored very rapidly. So I'll show you, walking through a query, how that would happen. And then the pack-to-pack nodes, again, are stored in memory and they're persisted and they're used in the context of establishing the pointers or relationships between the data and different data packs in the system. So, data comes in, metadata is created, data pack nodes are created, data is laid on disk in 64K chunks with the statistical information sitting in this metadata layer, and compression happens. Okay? Now, when a query comes into the system, there is, sitting off to the side, the MySQL optimizer. So some storage engines will just only use the MySQL optimizer. Infobright has its own optimizer. And depending on if there's a proprietary SQL statement that MySQL supports that we don't support, then it'll bop over to the MySQL optimizer, and performance will be at par of what MySQL is for the particular release that you ship with. But when the query goes through our optimizer, obviously it's hitting the knowledge grid, getting the information, and doing its thing, and getting data extremely fast. Okay? So what happens is the data packs, remember, they're compressed. And because we can eliminate data packs through this knowledge grid that need to be referenced and opened, we only decompress those data packs that are involved in the particular query and leave everything else alone. And that's where we get an incredible amount of efficiency. What you don't want to do with Infobright is do a select star. Because what happens, right, it decompresses, it has to go through everything, right? So that's why we say, look, when you're doing queries, you're better off referencing columns because you're not going to get this this hit. And we're always doing things to optimize the compression. Some people have said, can I turn that compression off? And we say, no. Well, why not? Because I do want to do some select stars. And we say, okay, well, we'll take that into consideration like any good product team would do. The other thing that I wanted to point out here was, oh gosh, it'll come back to me.
While you're thinking about it, I think I heard this correct. So, in the sense that there are some things that you haven't thought about optimizing yet or aren't in your sweet spot.
Yeah.
You'll just turn it over to the MySQL, which knows, but you're integrated with it, so it knows how to retrieve it through your storage engine.
Yeah.
So it's just an unoptimized query, but the functionality is there.
Yeah. Right now, a lot of work is being done in the code to optimize certain types of joins. So
can you give an example?
Left outer join. You know, I don't dare ask or talk to my VP of engineering about right outer joins because who uses right outer? So anyway, it's a joke. It's a
okay. Sorry.
That is the joke. It's
Wrong mode. Correlated subqueries, things like that?
Yeah. Anything on joins, anything on supporting like Star and Snowflake, really trying to make that run very efficiently. Deeper compression, things like that. We're having a blast. One thing I'll point out, which is really cool, that if you peer into the development process at Infobright, our iterations, we're using Agile and Scrum and all the good things that you hear about. And we're down into very fast, short burst iterations. So our iterations have dropped down from like 6 weeks down to 2-week iterations, could get down to 1. Now, how often we release? We're not releasing every week, you know. and because people can't take the, necessarily want to take and do the upgrade. Now, I will point out on the upgrade, it's very simple, because you just reinstall it, you install the newest version, you lay it down, and the data's already, even when you delete Infobright, we keep the data directory, and this is where all the data packs and things are stored, so we're very careful about that. The other thing, by the way, on the compression in this knowledge grid, it actually adds a level of security to the data. Hackers can bust into anything, as you well know. There's a normal database access security that's here, that's part of MySQL. But then trying to see data in the form of free text, you're not going to see it because it has to be decompressed.
Are there multiple levels of compression that are user choosable?
No.
Okay, so
No.
that's,
We take care of that behind you. And the other thing that this knowledge grid does is it really eliminates the indexing that you typically would need to do. So, yeah.
But this is a tremendous amount of work you're doing before the query even hits the database, right?
And we do it extremely fast.
Well, that's my question.
Yeah.
Is that how fast is this comparable? So if I'm doing my ETL and I'm inserting 1,000 transactions that I did that
Yeah.
day, it's the insert itself is going to be far slower than me doing that on an OLTP database, obviously. But is your value proposition that you're making it up on the query side?
No, I caution you to look at it that way. Like I said, the insert speeds are pretty fast. What we just tell people, if they're pouring in a lot of data into the engine, that you really need to think about not doing it via insert, but doing it via bulk load or batch.
Okay.
Batch chunks, because we're using a parallel loader in the Enterprise Edition to load that data in.
Is that what you're doing behind the scenes here? Because you're creating these data packs, right?
Yeah.
Which I'm assuming are sharded, right? You're not, or are you optimizing different pieces of data in different data packs?
Yes.
So
Yep.
you're doing some sort of sharding
Yeah.
in there too. So do you have like an optimal bulk size load that you guys sort of target that would create
No, what people
non-load
really
algorithms?
No, what people look for in our solution is how many gigabytes per hour we load.
Okay.
So things like 300, 350 gigs an hour is not unusual for us. So high-speed load and run the data. So they'll take the transactions, push it out through an ETL product. The ETL tools are generally like Talend, are using our bulk load API. So there's a native connector that can use that. Okay.
Are you making the assumption that the characteristics of the data, the histograms, aren't going to change over time, or a status-like feature?
Yeah, no, we're constantly,
Dynamically
yeah,
changing?
yes, exactly, keeping everything in sync. There are tooling that our engineers, if something gets out of sync for some reason, which we don't see happening, there are tooling that we provide. And then under the hood too there's a logging system, so you can always turn on the logging, and then if there's errors or the system crashed or whatever, we'll be able to pinpoint that pretty quickly.
So do you change the ranges of those 1,024 packs?
No.
so,
Yep.
so what kind of, are there tuning tools that users have access to?
There's probably less than there's less than a dozen
So are there
configuration
like
parameters.
statistics in the database
Yes.
that are keeping track?
Yep.
You can
And then
query
logging,
those.
logs, error logs and
But
things like
then,
that.
but there's no buttons you can push that are going to change. that's gonna
No,
change
there'll be
that.
configuration parameters that you switch on and things like that. Like, do you want like auto commit, right? Would be a parameter that you could set, right?
Right.
Or turning on what's called the Bright House, that's the internal name of our engine, error log on, so that if a query is failing, you would turn the error log on.
So is there like a configuration, like in a nip.ora that has
Yes,
any
yeah.
kind
There's
of
a Bright House configuration file.
What kind of numbers are you talking about for parameters that are jiggleable?
Less than 12. I forgot what the
Those
total
that work
is
with
now,
1900,
because it
I
changes.
think, too much.
Yeah, it's funny. That's
900.
that's the thing that we're trying to do is make it a self-managed database system. In other words, that you don't have to worry about this
You put a lot of
configuration.
people out of work then.
Well, no, actually, we'll put them on getting the product
interesting
developed and shipped
More interesting
really
work.
fast. Yeah, high value work. very high value. We're trying to shift you to one of the high
Well, I was
value.
thinking of like DBA, whose specialty is database tuning, if they switch over to you.
Sorry, guys.
Well, no, because there's still plenty of adjustment to make
Yes.
to change your schemas, right?
Yeah.
Yeah, oh,
ETL?
Somebody's not there already here.
Yeah. Plus, this is a system that's gonna work with the other stuff, so you can still, database tune all those other databases, right?
yep.
You can always introduce a NoSQL database and put it next to it, and then another one, and
Yeah, one of the things Infobright you'll find as a company is extremely focused on our customer success. We have to. We're a small company. We're less than 50 people, but we're growing fast. And one of the things that does cause a lot of bogging down is when there's a lot of configuration parameters. It's a big learning curve. What do these things do? How do you tune them and stuff? Trying to eliminate that nonsense. The same thing with indexing. Sometimes it's kind of weird with no indexing. So if you took the popular web analytics tool called PWIX and you did their database gen, you'll find that there's no PK, FK designators in there, so primary key, foreign keys, because the knowledge grid takes care of that all for you. And then there's no indexing in the system, so the create index statements basically fail. So you have to go into the schema generator, take out the create indexing, and then there are certain data types, like we don't support the blob or character blob data type, so if it gens, you'll have to switch that to long varchar or long text or whatever.
Do you work with standard report writers?
Yes, yeah. We have a lot of success with, we're certified with MicroStrategy, so that means that we are supported as a native database for MicroStrategy. They've been great to work with. I'll just point this out, if you're a MicroStrategy, anybody use MicroStrategy here? No, it's a great analytic engine, and they do a lot of testing with the databases. You cannot, as a vendor, you can't say, yeah, I work with MicroStrategy without going through their very rigid test process and suite. We have their test suite inside our company. They have their whole database testing team, and they are brutal. Like, you can bet if it's working with Infobright, it's supported, and they're going to fix, and we're going to fix if anything shows up. Just a comment about things when you look at, that's a really good thing that they do. We're really impressed with the team and working with them through this test process. And they found, frankly, a few bugs through the testing process that we go, wow, really weird stuff. But, we picked it up and we fixed it and we got on, so really good stuff. Talon, Jaspersoft, we have people using business objects with us. We're not certified. Cognos, we're not certified on them, but people do use us. So rewind a little bit. When a query gets executed, this is kind of like a graphical picture. Things in this query get eliminated really fast. And so the suspect and the actual values that are matched inside the knowledge grid, all these other things will get ignored, and these will get delivered, and it's extremely accurate. Okay. In the underpinnings of the engine, this is a high-level architectural picture. So all the standard MySQL connectors. So if you're, we've got a great white paper on using Visual Studio with us through the MySQL.net connectors. Whether you're using ODBC, JDBC, just go to the MySQL, download them, and they work. We have our loader, the optimizer and executor, and then again, we also, because we ship with MySQL, will be under, they'll have the optimizer also access. And then the underpinnings of the core engine, where the data is then laid down on disk. What's interesting about Infobright, this was done before my days landing there, but you talk about in-memory databases and using flash or SSD for storage, and what we're finding out is it's not actually that much of a difference in performance because of the nature of the way we operate. We're not always picking up everything off disk to deliver, right? So,
But if you were on, what you were stored was on SSD.
yeah.
When you did go to
Well, yeah, that might obviously help.
So do you have rule of thumbs as to?
No. We're not doing any things any special sauce in the engine to say, oh, part of that disk is, part of that storage is on flash and part of it's on storage, so do your thing. Although, interesting idea.
Well, and this is based on MySQL, but you have your own version, an
Yes.
edited version of that?
Yeah, in fact, that's a good point, Mark, is we are an official OEM of MySQL, of Oracle. We're an OEM of Oracle.
Sorry.
What that means is we have our own distribution, and therefore, you know, we do have to pay something back to them for that distribution, and because you pay, you're serviced. In other words, if we have issues or we need some help, there's a relationship there that's pretty
Do
deep.
you release that as open source?
Yes. Yeah, we have a GPL version that has MySQL with us, and then we have our commercial version.
Are you gonna go the plugin route like DB did, so you don't have to keep up with the release of MySQL?
No, that's because of the arrangement that we have with Oracle. We have to,
And you wouldn't want to, because part of it is, you're not just a storage engine, you're also the
Right.
optimizer and all
Right.
that stuff.
we have to do our,
You would
testing.
want that.
If you want to mess around with that optimizer, you have to look into it.
Right,
Yeah.
right, yeah.
Yeah.
Tokutech does the same thing, where it doesn't make sense to have the storage engine without the added optimizer features too.
yeah, there are other forks of MySQL. Some of them were mentioned earlier in the meeting, where we have our own distribution.
So you're on 5.1 right now as well, or no? MySQL 5.1?
Yes,
You get a distribution there?
Now, the thing that you have to be careful here is commingling a commercial offering and linking it into the GPL offering, right? Right, you can't. That causes confusion and a lot of debates.
When
So
you say,
the enterprise edition, for example, if you're an OEM, if you want to OEM us, you're not gonna be able to do it with a GPL, especially if you offer commercial. But if you're a GPL, that's fine.
so you're talking about MySQL GPL and Infobright GPL?
Yes.
That's what you can mix?
That's the community,
Yeah,
yes.
and you can mix commercial and commercial, but you
Right.
cannot do that?
No, we won't, unfortunately, we won't go down that path.
Now I'm confused. Sorry. So what is,
There's two Infobrights. There's Community Edition, which is GPL, free, open, has MySQL GPL with that.
some flavor of 5.1
Yeah.
changed by you guys
Yeah.
and re-released as GPL?
We don't change anything in the MySQL code line.
Oh, okay.
Yeah. And then there's the commercial edition that has a commercial license of MySQL. That's it's a commercial stack.
Why would I go the commercial route?
You want an economic relationship with us, you want support, you want services, you want bug fixes, patches, things like
Red
that.
Hat.
Yeah, well, no, because you're actually buying a subscription to the software. Yeah, it's not a
Right,
perpetual.
but the software
license.
itself isn't different.
I thought the.
There is differences between Community Edition and
What are
Enterprise
those
Edition.
differences?
Great question. Community Edition
That
does
was,
not.
that was his question, I
Yeah,
told
Yeah,
him, so it
yeah,
wasn't
yeah,
such a
oh,
great
I'm sorry,
question.
I'm sorry, yeah, I missed that.
Wasn't originally my great
It's
question.
a good thing that, well, the
It's
first
not a
one,
question, I just screwed it all up.
well, we were just talking about the first big difference is commercial versus GPL too, right? The other differences are, in the Community Edition, there's no DML, there's no insert, update, delete. You have to load and go, you purge, load and go. Okay. So there are some very large companies using the Community Edition. I know it sounds kind of strange, but it is. It's using the loader, MySQL loader, load the data, do the queries. The data may not change for a month. They load it again. There's a very large telecommunications company down in Virginia that uses us.
Hard to figure out that one.
Before the commercial version being a large.
No, I think it's because the company has had the CTO of the company has said, we only use open source. So I will back up on that. You can use commercial, but you better present a very compelling reason if there's an open source version out there and you can compare with it. They love the product and everything, but they They use the community edition. It would be nice if they had an economic relationship with us, but we're happy to support them. Yes.
Just a quick question, I'm gonna have to roll, sorry.
Oh, sure. I'm sorry, you have to leave.
No, that's okay. So since you have MySQL integrated, can you run both the stock MySQL and this on the same machine?
Yes. Yeah, you have to.
Be sure.
Yeah, I just saw this. No.
In other words, if I install this, do I blast the regular MySQL?
No, it won't. There's been a big, long threaded discussion on our forums about this, about the multiple instances. I think there's a whole how-to.
Okay.
There's a how-to white paper to get them to run.
So check the docs before doing it.
Yes,
if
yeah,
possible.
yeah, for sure.
Okay, thanks.
So, one more quick question. There's a lot of deployments that we've seen where there's a master and slave configuration, where
Yeah.
the slave has a role in reporting, etc. So can the master be a simple DB,
Yep,
and then it
Yep.
replicates out to your stuff?
Yep.
But then it's constantly up to date, right?
yes.
Okay.
Yep.
Will your replication pick up the,
It's Infobright to Infobright replication.
so it won't work with MySQL?
You know, that's a good question. It hasn't, I don't know, actually. Never tried it.
You got it for free.
Yeah.
It's
Right,
just-
well, the answer is that's probably a bad idea, only because most people who are doing stuff like that are using replication instead of doing ETL.
Yeah.
Yeah.
And really, the point is to get people away from the,
It's a
I have
very
this
good
great
point,
OLTP thing, let me have 70 read slaves that replicate, and then we just do our reporting on that. And then just keep adding those read slaves because people are doing crazy reporting queries.
There's actually specific use cases for that. I used to be in that camp as well. That you ought to think through your schema and do it right into ETL. There are, the use case is just a very heavily write database that you need ad hoc reporting on.
Oh, right, and there's always going to be ad hoc reporting, and you know, I'm not saying that everyone should get rid of all their read slaves. I'm sure that some read slaves are appropriate, if only for reading transactional data, right? But for the data mining stuff, a lot of people are using the read slaves for the data mining because it's there. Basically what happens is they start tracking stuff and it gets into the database, and then people are like, well, if we have it in the database, let's data mine the database, and there's no money or time for a big project to do this data warehousing thing. We just want data, you know, we just want all the information out of the data without doing a big data warehousing project. What's the problem?
Just
So,
one
yeah.
real quick one.
Sure.
If you do, take standard MySQL,
Yeah.
and you can do an explain, let's take a fairly complex
Yep.
query. What do you see when, and number one, do you support
No.
the explain? Okay. So that you don't see anything if you're trying to figure out what you're doing.
I might have missed it, but I asked a question earlier about how the columns are tied together with if there's an internally.
The pack-to-pack nodes for how they're joined.
Well, let's say a.
Well, at the highest level, it's the knowledge grid that keeps reference points to the data pack. So a query comes in.
But in other words, if you have a table of data and you have your employee ID and first name and last name,
Yes.
whatever, and you have different kinds of compression on each of the columns,
Yeah.
you know, depending on character, numeric data.
But we're not compressing the entire column, right? We're taking the data, breaking it into 64K packs, compressing that. So if you had a column of employee IDs, for example, right? So we're gonna take those employee IDs and bust them up into these 64K chunks, compress those.
So yeah, I'm just still not seeing how you tie those compressed IDs to the compressed names. You know, you associate the right ID, the right name if you write a query that both come back.
Okay, the query comes in, right? The knowledge grid determines where the data packs are available that satisfy the query, thank you. Decompress and deliver.
Independently, both of them.
Yes.
So one of these
Knowledge grid knows
Yeah, but
about
there's
that.
something has to tie, and I'll let
Knowledge
go
grid does
follow
it.
after. Something has to tie
It's
that
those
ID to
two
that
concept of
name.
rows.
You know, when you decompress the data, you find that the places where the data exists, and you decompress them. you still have a, you know,
Well, if everything is like the third entry in a particular, you know, it's always gonna be the same entry in each data pack that has to line up.
No. There can be
No,
no.
Yeah,
no,
No?
No.
Well,
That'd be too easy.
These
So
things
if
are
you
wrong.
ask
That's the
if you ask
question,
the
how you line
question,
things up.
maximum age in the column of ages,
Yeah.
and then you want to know the name of the guy that has that maximum age. How
So
do you
your
traverse-
query looks for that,
But so how do you?
then
tra-
you construct
how
the
do you, do
query.
you know the?
So you say,
Yeah.
so you formulate your
If the
query to
name
get
of
the
the
max
guy who's-
age and then ask for the first name or the last
Right,
name
but
or
how
whatever.
does
does it know the
underlying,
type
how does it know that
Because-
this part of this column goes with this part of that column?
You don't have to think like this. You just don't.
It wants to know how to
I
underline,
can't
Here's
go
a bunch
into
of
the.
road guys.
It would be yeah. I mean, it would be kind of digging down into.
Question. So, you know, for me, it's like, you know, running it with my data. So, what you're saying is, this is with getting your data into it as sort of like a reporting database. It can become your master reporting database, where like you do like a nightly build and dump to it. Are there built-in tools that can attach directly to an existing database, or do you have to create your own ETL to spit it into some table structure? Like how do you? So I have a MySQL database with probably about 8 databases.
Yeah.
That obviously that highly normalized.
Right.
That needs to get flattened in some way to be put into there, or does it literally just take those databases?
No, there's not. Literally, you don't have to worry about the schema. You just take the data, pop it into our loader. Pop it to our loader, and then write into. You have to create the database. So.
Okay.
But you don't have to worry about.
What columns?
Yeah, you don't have to worry about like how it gets set up and everything.
But there's you said
So if you have 8 databases over here and you create 8 databases over in Infobright, you can just move those over to Infobright using extract, transform, or load, or unload, and load.
Do you have those tools like where?
Oh,
you
we use
can
some MySQL tools.
just dump
Yeah,
MySQL
yeah,
dump,
exactly.
MySQL. So I can
Yeah.
just dump everything
Yeah.
and import
Yeah.
everything.
Yeah.
Now, but with the highly normalized structure of the databases, the joining limitations and stuff like that, doesn't that potentially cause a problem?
You're saying that in your existing MySQL database, and you have all these joins.
Well, I have a whole bunch of like tables that are like I said, very very normalized. So
Yeah.
everything has to go through like.
Yeah, I would say give it a shot. Pull it over. I just don't know enough about the schema on the database to give you a sense of what it is, but I would give it a shot.
Okay, but
Just
so
take one of the databases.
If you change the scheme, you're gonna change the
I
targets.
want to make sure you understand is like the joining is not horrible in this.
okay, it just
We're
you take
trying to-
you take a hit anytime. But if you
Yeah,
flatten out.
every database does. Every database engine out there does work to optimize the joins.
But if you flatten out the data and create sort of like a
More
data-
towards a thinking in terms of columns.
and then load it.
Yeah, anything that where you can take away joins are going to be faster. This is the no SQL argument, right? They're saying we don't even support joins, so don't even think about that because joins bogs down. It's a complex.
So you don't get any kind of penalty for like extremely wide tables?
No, not at all. In fact, we get big benefits out of that.
You will get a penalty if you try to select everything from the table, like you said,
Yeah.
select star. If you
Yeah,
try
'cause
to
you're going
do
to a
something with every
decompression.
column in there, then yeah. So if you had something like a lot of flags or something,
Yep.
that wouldn't necessarily still be a good, like if you're, let's say you have like
Hard to tell.
I don't know, a dating site and you, like everyone has like, oh my eyes are blue or my eyes are, you know,
No, we'll
brown
be
or
able
my
to-
eyes whatever.
No, those.
I mean, but you have like 20 of them that you're querying.
Yeah, we
Does
should
that-
actually do very good on that.
Okay.
Yeah.
I'm still struggling to understand. So assume in my original database I have orders and items, and
Yeah.
you say load it into this thing. How are you going to know that orders and items are related and put it in a flat table? I probably
We don't have to know.
You have to do that. That's
I
that's
think I have to
that's the
educate you a
del.
little bit, right? So say there's a relationship. This is a foreign key into that.
But that's
No,
why you
no, no.
denormalize it. You denormalize it. You put them as if you're now putting it into like an Excel spreadsheet. Where you
I
say,
understand, but
okay.
in order to do that, you have to know that that relationship exists, and I've studied quite a
No,
bit.
no, the relationship gets created through the joining of those two tables, between the relationships of those tables.
Oh, so will eventually you query, and sooner or later it starts realizing, hey, these two
Yes,
tables are
yeah,
getting joined
yeah,
a whole
definitely, yeah.
lot,
Yep.
and then it. Okay.
Yeah.
So
you analyze queries before you know it.
Yeah, we're always looking at the queries, yeah. We have to go through the optimization, we have to go through the planning, we have to
I
go
don't
through
think
the
that's-
execution.
I think you guys missed there. That's not what, I mean, I could be wrong, but I think that's what you meant. You're not analyzing,
When the query comes in,
yeah,
right, it's pushed down to us, we get a tree, right? We use our optimizer, a planner, and an executor to execute on the query. And then we use the knowledge grid and the various nodes to take an efficient path through resolving the queries and delivering the data back.
I get that.
Right. So in the work that's being done to optimize joins is in the underpinnings of the system for the joining algorithms. So those.
But in a non-joined case.
Yes.
Just simple stuff, you know, name, number, that has intrinsic value in a relational database. Bob, 5, Lionel, 3.
Yes.
Those are now columns. It's Bob and Lionel.
Yeah, but it's on disk in the form of columns. But when you're, oh, maybe this would help. When you're looking at things, it looks like a relational database. You're not looking at columns.
Grid creates a relational database.
Yeah, we
somehow.
support the relational model. So when you look at tables and stuff like that, you're not
Storage
looking at
versus-
columns. You're looking at whatever your schema is that you created.
I get that. So
Okay.
when I say my
But it's on disk, as laid down on columnar
So-
fashion on disk.
C-
Sorry,
do you mind-
Lionel, I
Do you
don't
mind if I
mean
try
to-
just one more time?
Sure, yeah.
If I have the query, select where name equals Bob
Yeah,
and Lionel equals 3.
yeah,
You're going down your column of data, you're dividing that up, your optimizer's coming in, you're dividing that up, you're finding Bob,
yeah,
and you're finding 3.
yeah,
Got that, I'm really good with that.
okay.
Now I have another column
Great.
that I want to get back that's related to that, and it's just in my projection, it's not in my filter.
We don't, okay.
You don't,
Okay, so.
so how do you know where the value is of that other column that you're going to give me back with Bob and 3 and the value of that other column?
It's stored in the knowledge grid.
yeah.
The knowledge grid has the metadata, it has the ranges of information, and it has the, remember the
That's where the
C-maps and the histograms. It's all laid out in that,
So
like,
you can get it, you can
The knowledge
build
grid
back the rows,
contains the
basically.
interrelationships.
yes,
Yep.
yeah,
Yep.
exactly.
I missed that.
Okay.
Does that perform better than the actual, the original database with indexes and just for, having to
because
like
that's
references?
it's important thing.
Indexes.
Yeah, I mean, you might do some queries that are static, that use indexing technique, that actually may run slower, they actually may run faster. It depends on the query, it really does, and how much data and things like that. What I will say is certain things like aggregates and sums and ranges of value, it doesn't even have to go to the disk. It just pulls it out from the knowledge grid, which sits, that information will sit in memory. And things will get, which is interesting because sometimes you'll hit a query and then you'll run it again and it's like, oh my God, what happened? Because there's efficiencies, there's work being done under the hood. These are real customer performance. See, we don't talk about TPCH, we talk about real results here, right? And this is the biggest challenge for our company is getting people to try us out, right? So downloading it, because when they do, they get this wow. So in the case of one of our customers, Bango, they grabbed the community edition. They said, oh, we're really bogging down with SQL Server. We put it over in Infobright, tried it out, and we couldn't believe it. It was like, wow, this is amazing. It's dramatic. So they started moving more and more, and eventually they said, hey, we need to do a deal with Infobright and actually execute on it. So these are all the things that we're good at, that we've been talking about, data marts. Generally, you don't want to use us for a big, massive enterprise data warehouse project. You wouldn't necessarily say you want to use this for that.
So mostly for data marts.
Yeah, the things that are like in the 7 to 10 to 20 terabytes. So if we look at Bango, again, this is a leading SaaS-based mobile billing and analytics. So when you're looking at ads on phones, they pick up all kinds of. They have actually. They don't use page tagging. They use a kind of an image on the ad to track, which is kind of interesting. They have an interesting approach. It's a cool company. They got this big contract. They had SQL Server. They were getting 150 million rows per month. It was generating 450 gigs here, a lot. And the queries in SQL Server were in this range here for certain reports that are, again, the reports are required by the subscriber, in this case, the media company. So when they went from 29 minutes to 8 seconds, and 43 minutes down to 23 seconds, and 11 minutes down to 10 seconds, these are their existing queries that were running against SQL Server, generate that report. When they moved it over to Infobright, that's the kind of results they got. So, you know, this is pretty dramatic, and this is where, again, I talk about the challenges of the company is to get more and more people to see that dramatic change and say, wow, you know, I'm going to give this a shot.
Can we get this presentation after?
Yes. Yeah, I'll get
Yeah,
it.
that
Sure.
will be great.
Yeah, everything's, we don't have too many secrets. We really don't. You know, we're pretty wide open. We can't give out revenue numbers or anything like that. That I guess is probably our biggest secret. But we're doing well. Austin Energy, thanks, Lon. Good seeing you.
Good to see you.
Thank you for coming. Austin Energy, again, it's a great company down in Austin, Texas, and they are an energy company. It's pretty large. They had a particular project where they were requiring an executive dashboard, and they were struggling to get this thing delivered, and it had to be pretty low cost, so they wanted to take advantage of open source technology. They grabbed a hold of, there were only two project people on this particular project, and they are absolute heroes now. I mean, now everybody wants these dashboards in the different business units. And what happened is they had to do a lot of consolidation, so there was ETL, there was other database technology that they had information stored on, pulled it into Infobright, and this is the kind of results they were getting. So the data volumes, they were able to support 1 month of data. Now they can get 2 years of data and get these fast queries against very large sets of data. The compression over here compared to compression here. And in the Bango's case, it actually, I think, easily doubled and tripled in size of the database in SQL Server. So this is a case where they're getting 98 to 1 compression, which is, we don't see that too often, but that's what they tell us that they're getting. So the 5 gigabytes now occupy just a little over 100 megabytes. So they're able to keep a lot more data, so the currency is larger. And then the reporting time, they were running once per month, now it's on the fly, so less than 10 seconds on the report. Okay. So continue to work with our technology. It's a great team to work with. So a lot of time to value here. The MySQL compatibility. You don't have to worry about partitioning and indexing. We're self-tuning, self-managing, not a lot of configuration parameters. You can use the MySQL Workbench tooling, things like that to interface. I use PHP-MyAdmin because I just
Because you're not
I
a
can
DBA.
do well. I
You're
do
a
the
CEO.
command line,
It's
but I
okay.
want to look at things more holistically when I'm working with the engine, and then we get great performance at much lower cost. So if you want to try us out, there you go. And I have we don't run on the Mac, unfortunately, but you know, after you install. After you install Infobright, you know, you'll see the Infobright start and stop and then our command line here. So it's actually, so here's, I have we have I don't know, several 100 million row sample database that you can download from a community site called Car Sales. And
So if you type show engines, you
let
will
me
see
say,
that.
use Car Sales. Subtables. So it just, those are sitting in, Infobright. Okay, obviously, because I'm going to the console. But I think if I actually were to run that query again, what was it? I forgot. Speed, you'll see it probably is shrunken.
You couldn't read the query.
Yeah, so it went from 0.11 to down to 0.2. You can see. It was using select asterisk, so the question was happening.
Is that because of query caching, or you just optimize the query with
Both.
the knowledge?
Both.
Okay.
Yep. So, very MySQL ecosystem friendly. The skills, the kind of interactions with it, things like that. It looks like a relational database. You don't have to think query. You don't have to put your query heads into column form. You just put it into your normal tables as you interact. So, any questions, comments? Hopefully this is helpful. Hopefully I was able to answer your questions and give you some good insight onto the product. It's a fun product. And a lot of people are becoming heroes, taking advantage of it. They're really having great success. And we're not without our bugs and things like that. But the good news is that conversation that happens is all wide open. So you can go into our forums and say, do a search on server crashing or whatever, but you'll see us be extremely responsive. The really cool thing about our forums too, when you have technical questions, the actual software engineers will respond, which becomes a challenge to our VP of engineering because they'll say, hey, they should be coding. But they get up early and they get in there and participate actively, and that's what you would expect from this open source world.
So in a commercial environment, what's your price structures compared to some of the big companies' price structures? I know Oracle's is outrageous.
Yeah, pretty dramatically low. You can always go to.
Yeah, it is.
We are priced on a per terabyte basis, so we're not CPU priced or server number of servers.
Is that
or
before or
sockets
after
and things
compression?
like that.
What's
Pre-compression. Sorry.
That's how it's usually done, pre-compression. I know. I
You'll have to
had
talk
ask.
Look, with any software, I mean, you all know this. Some of you are in the software sector. You've dealt with vendors, things like that. There's always negotiations. So these prices are like the starting price.
Can you zoom that a little?
So there's a lot. What's that?
Can you zoom that up a little bit? Or
What surprised me is that you are more costly than MySQL itself.
We are.
But they do more than MySQL.
Yeah, if you could do something in 11 seconds.
Well, no,
versus
actually,
4 hours.
we're cheaper because there's the community that's in it.
No, I'm talking about commercial version.
Yeah, this is price competitive with the data warehouse, data analytic database.
Yeah, they're in a different range
Yeah.
of prices.
Yeah. So we have the various subscriptions, and then these are annual.
The 21,000 is for what?
Platinum.
Platinum.
Yeah,
Yeah, that's
I
like
see that, but for what kind of volume?
1 terabyte.
It's
terabyte.
that's per terabyte per year.
Yeah.
21
So for
terabyte
a
per
5
year?
terabyte database, it's 100K.
Yeah.
Well, it's like I
Wow.
said, you have to put your good negotiation hat on. But if you were to use our
Wow.
list prices, that's what. it
But
would
that's
be.
also
But you
for
don't have to give that
7
away
by
in the first
24 by
conversation.
yeah. That's also for 7 by 24 by
That's what
365
Yeah.
with 1 hour response on a severe issue.
yeah.
So that would be worth 100K if you need that report right now. No, I'm just saying that I've seen reasonably priced things and I've seen not reasonably priced things. I actually almost died because I thought it was gigabyte and I was like, that's ridiculous.
No.
But then I realized terabyte.
Yeah.
I mean, you said for a 5 terabyte database. Did you have a 5 terabyte?
Yeah, we have,
warehouse?
we have,
If you do, you're probably
Yeah, but-
making a lot more than $5 grand
Yeah,
a year.
exactly.
A year
Exactly.
difference.
I mean, just to store the data.
I thought that was my music database at home.
we have,
Community edition.
Thank you, Bob.
thank you very much. You got a great audience.